Happy morning, children. Hope you all are fine and safe at your home. We have seen the first two parts in the second lesson, mechanics. Shall we recall what we have seen in first two parts? Yes. We have seen the various branches in physics, namely mechanics, statics, dynamics. Dynamics is divided into kinetics and kinematics. Then we have seen what is rest. If a body does not change its position with respect to time, then it is called as rest. If a body changes its position with respect to time, then it is said to be in motion. Then we have seen various types of motion, right? We have seen what is velocity, what is acceleration. Is what is velocity? Velocity is rate of change of displacement. What is acceleration? Acceleration is rate of change of velocity. Yes, the unit of velocity is meter second power minus 1 and the unit of acceleration is meter second power minus 2. Now we are going to see the rest of the parts in this second unit. Okay, the first topic that we are going to see is acceleration due to gravity. What is acceleration due to gravity? What is gravity? What is gravitational force? The force which attracts the particles towards the earth's surface is called as gravitational force. The force which attracts an object towards the surface of the earth is called as gravitational force. Now, what is acceleration due to gravity? What is acceleration? Rate of change of velocity is acceleration. Now, what is acceleration due to gravity? Rate of increase in velocity of a freely falling body due to gravity is called as acceleration due to gravity. Rate of increase in velocity of a freely falling body due to gravity is called as acceleration due to gravity. Gravity is nothing but attraction. Okay, an object gets attracted towards the earth's surface due to gravitational force. Yes, the value for acceleration due to gravity on earth's surface is 9.8 meter second power minus 2. The value for acceleration due to gravity of earth's surface is 9.8 meter second power minus 2. Next, on the surface of the moon, the acceleration due to gravity is 1.63 meter second power minus 2. On the surface of the earth, the acceleration due to gravity is 9.8 meter second power minus 2. On the surface of the moon, the acceleration due to gravity is 1.63 meter second power minus 2. Then what is uniform acceleration? Uniform acceleration is nothing but the ratio of change in velocity and time. The ratio of change in velocity and time is uniform acceleration. Change in velocity is nothing but final velocity minus initial velocity. Change in velocity is nothing but final velocity minus initial velocity. V is your final velocity and u is your initial velocity. T is time taken. So uniform acceleration is change in velocity by time taken. Yes, next. Now from this formula we are going to calculate what is velocity. Okay. A is equal to v minus u by t. V is your final velocity, u is your initial velocity and t is time. Now if you cross multiply this t will goes to this. At is equal to v minus u. Now v minus u is equal to at. From this if we calculate v is equal to at minus u goes to this side and becomes plus u. Is it clear? Acceleration is equal to change in velocity by time. Change in velocity is nothing but final velocity minus initial velocity by time. Now at which is equal to v minus u. If this v minus u is equal to at, I am interchanging this two components. V minus u is equal to at. Now this minus u goes to the right hand side, it becomes plus u. V is equal to at plus u. Now to write it in a proper form, I am writing it as u plus at. What is the formula for velocity? V is equal to u plus at. Here v is your final velocity, u is your initial velocity, a is your acceleration, t is time. V is your final velocity and u is initial velocity, a is your acceleration and t is time. What is the formula for velocity? Velocity which is equal to u plus at. Now if g is positive, g is nothing but acceleration due to gravity. If this g is positive, here a is your acceleration, this a is replaced by g. G is your acceleration due to gravity. V is equal to u plus gt. V is your velocity. S is equal to ut plus half gt square. S is your displacement. This S represents displacement. Displacement is equal to ut plus half gt square. G is your acceleration due to gravity. Next, p square is equal to u square plus 2g. Yes, p square is equal to u square plus 2g. Yes, if g is negative, if acceleration due to gravity is negative, v is equal to u minus gt. If g is positive, v is equal to u plus gt. If this g is negative, then v is equal to u minus gt. Displacement is equal to ut minus half gt square. Next, p square is equal to u square minus 2g. Yes, if this g is positive, all the values will be in positive. If this g is negative, all the values will be in negative form. Okay. Next, we shall see a problems related to these formulas. I will read a question for your first problem. Listen carefully. A car starts from rest and is accelerated at the rate of 3 meter second power minus 2 for 8 seconds. Find the velocity of the car at the end of 8 seconds. See, I will read the question again. Listen carefully. A car starts from rest and is accelerated at the rate of 3 meter second power minus 2 for 8 seconds. Find the velocity of the car at the end of 8 seconds. See here, they have given the value for acceleration. The value for acceleration A is 3 meter second power minus 2. And they have given us the value for time. Time is 8 seconds. They are asking us to calculate velocity of the car. What is the formula for calculating velocity? U plus AT. What is the formula for calculating velocity? Velocity is equal to U plus AT. They have given a car starts from rest. Initially the car starts from rest. So the initial velocity is U. Initial velocity of the car is 0. Initial velocity of the car is 0 as the car is at rest. Okay. Next, acceleration value is given there. Acceleration A is equal to 3 meter second power minus 2 and time t is equal to 8 seconds. They are asking us to calculate the velocity of the car. What is the formula to calculate velocity? V is equal to u plus at. Yes, what is the value of u given here? U is 0 plus what is the value of a? 3 meter second power minus 2 into 8 seconds. So what is the answer? 24 meter second minus 2 plus 1 is minus 1. The value for velocity is 24 meter second power minus 1. Is it clear? See, they have given a car starts from rest. So the initial velocity of the car is 0 and is accelerated at the rate of 3 meter second power minus 2 for 8 seconds. Okay, acceleration value is 3 meter second power minus 2 and time taken is 8 seconds. They are asking us to calculate velocity of the car. Velocity which is equal to u plus at. U is your initial velocity. As the car starts from rest, initial velocity is 0. U value is 0 and acceleration value is 3 meter second power minus 2. Time taken is 8 seconds. Okay. S power minus 2 into S power 1 is secant. S power minus 2 into S power 1. Minus 2 into plus 1 is minus 1. Okay. So the value for velocity of the car is 24 meter second power minus 1. Is it clear? Yes. Now, see your next problem. I will read the question for you. Listen carefully. A motorbike is moving with a velocity of 8 meter second power minus 1. It is accelerated at the rate of 0.8 meter second power minus 2 for 20 seconds. Find the final velocity of the motorbike. See, a motorbike is moving with a velocity. They have given a value for velocity 8 meter second power minus 1. It is accelerated at the rate of 0.8 meter second power is given there, acceleration value is also given there for 20 seconds. Time value is also given. We have to find the final velocity of motor bike. Initial velocity is 8 meter second power minus 2. We have to find the final velocity. What is the formula to calculate final velocity? V is equal to U plus AT. Initial velocity is 8 meter second power minus 1. Acceleration value is 0.8 meter second power minus 2 and time taken is 20 seconds. If you multiply this, see 0.8 into 20 is 16. 16 meter second power minus 1 plus 8. The final velocity is 24 meter second power minus 1. See here they have given us the value for velocity, acceleration and time taken. They are asking us to calculate the final velocity. The formula to calculate final velocity is V is equal to U plus AT. Hence U is a initial velocity. The value for initial velocity given here is 8 meter second power minus 1. Substitute all the values in the formula and hence the final answer is V is equal to 24 meter second power minus 1. Yes. Is it clear? We have seen what is acceleration due to gravity. Acceleration due to gravity is rate of increase in velocity of a freely falling body due to gravity. The value for acceleration due to gravity for Earth's surface is 9.8 meter second power minus 2 and on the surface of the moon the acceleration due to gravity is 1.53 meter second power minus 2. Then uniform acceleration is change in velocity by time taken. A is equal to V minus U by T. V is your final velocity and U is your initial velocity. If you cross multiply this, AT is equal to V minus U. V minus U is equal to AT. Hence V is equal to AT plus U. To write it in a proper form, I am writing it as V is equal to U plus AT. Is it clear? If this A is replaced by G, where G is your acceleration due to gravity. V is equal to U plus GT. If G value is positive, all the values will be in your positive sign. If G value is negative, then all the values will be in negative form. Then we have seen two problems based on this formula. Is it clear? You might have seen the first part of your second lesson, mechanics. Now we are going to see the remaining part of the lesson. Is what are the topics that you have seen in the first part? You might have seen the definition for rest, motion, and you might have seen the difference between rest and motion. We have seen various types of motions, namely random motion, translational motion, rotational motion, oscillatory motion. Translational motion is further divided into three types, namely rectilinear motion, curvilinear motion and circular motion. We have seen various statements that are given by various scientists, namely Aristotle, Galileo and Newton, right? Now we are going to see what is force. Yes, what is force? You would have been studying the definition of force from your lower classes, right? Yes, what is force? Force is a push or pull of an object. Force is a push or pull of an object. Force is a push or pull acting on a body which changes or tend to change the state of rest or motion. Okay. Force is a push or pull of an object which can change or tend to change the state of rest or motion. What is force? Force is a push or pull of an object. Force is an external agency applied on a body to change its state of rest and motion. Okay. What is force? Force is an external agency applied on a body to change its state of rest and motion. Next, there are various effects of force. We are going to see what are all the effects of force. Next, first is force can make the stationary objects move. Force can make the stationary objects move. Is what are called as stationary objects? The objects that are at rest are called as stationary objects. The objects that are at rest are called as stationary objects. Force can make the stationary objects move. Force is applied to move the objects that are at rest. Next, force can make the moving body stop. Force can move the bodies that are at rest. It can make the bodies that are moving, force can make the moving body accelerate the moving bodies. Force can accelerate. Accelerate is nothing but increase the speed of moving bodies. Force can increase the speed of moving objects. Force can change the shape and size of a body. Force can change the shape and size of a body. For example, if you take an orange, if you squeeze the orange, what will happen? The size and shape of the orange will change. So force can change the shape and size of a body. What are the various effects of force? Force can make the stationary objects move. Stationary objects are nothing but objects that are at rest. Force can make the moving body stop. Force can change the direction of motion of the body. Force can accelerate the moving objects. Accelerate is nothing but it can increase the speed of moving objects. Force can change the shape and size of a body. These are the various effects of force. Next, there are two types of forces, namely balanced force and unbalanced force. What are called as balanced forces? Forces that are equal in magnitude but opposite in direction are called as balanced forces. Forces that are equal in magnitude but opposite in direction. These forces can make the object to remain in a state of rest or motion in a straight line. For example, tug of war. Have you ever played the game tug of war? What is the game tug of war? Tug of war is nothing but there will be a rope. There will be two teams on the opposite side. They have to pull the rope. Who pull the rope first, they are the winners. That is tug of war. Tug of war is a game. It is an example for balanced force. Next is your unbalanced force. Unbalanced force is nothing but if the resultant force is not equal to 0. If the resultant force is equal to 0, then it is called as balanced force. If the resultant force is not equal to 0, then it is called as unbalanced force. Resultant force is nothing but two or more forces are represented by a single force called as resultant force. If the resultant force is not equal to 0, then it causes the motion of a body due to unbalanced force. For example, force on a weight balance, and see here a man is pulling the cardboard towards the slope. This is unbalanced force. There is no balance between the box and the man. This is an example for unbalanced force. Example for balanced force is tug of war. Example for unbalanced force is weight balance. Okay, we have seen what is force. Force is a push or pull acting on a body which changes or tend to change the state of rest or motion. There are various effects of force, namely force can make the stationary objects move. Force can make the moving body stop. Force can change the direction of motion of the body. Force can accelerate the moving objects. Accelerate is nothing but increase the speed of moving objects. Force can change the shape and size of a body. Next, balanced force and unbalanced force. Balanced forces are nothing but if the forces are equal in magnitude but opposite in direction. If the resultant force is equal to 0, then it is called as balanced force. If the resultant force is not equal to 0, then it is called as unbalanced force. We have seen what are balanced forces and what are unbalanced forces. What are called balanced forces? Balanced forces are nothing but if the resultant force is equal to 0, then they are called as balanced forces. If the resultant force is not equal to 0, then they are called as unbalanced forces. Now we are going to see the difference between balanced force and unbalanced force. Yes, what is the difference between balanced force and unbalanced force? Balanced force do not change the state of rest of a body. Balanced force do not change the state of rest of a body. Unbalanced forces change the state of rest of a body. Balanced force do not change the state of rest of a body. Unbalanced forces changes the state of rest of a body. Next, balanced force do not change the state of motion of a body. Balanced force do not change the rest of a body, and it does not change the state of motion of a body. Unbalanced force or decrease the speed of a moving body. Unbalanced force can accelerate or decelerate the moving body. Accelerate is nothing but increase the speed of the moving body, and decelerate is nothing but decrease the speed of a moving body. Next point is balanced forces can change the shape of the body but not the direction of a moving body. Unbalanced force can change the shape as well as direction of motion. Balanced force can change only the shape but not direction. Unbalanced force can change the shape as well as direction of motion. Is what are the difference between balanced force and unbalanced force? Balanced force do not change the state of rest and state of motion of a body. Unbalanced force can change the state of rest and motion of a body. It can accelerate or decelerate the moving body. Accelerate is nothing but increasing speed. Decelerate is decreasing speed. Next, balanced force can change the shape of a body but not direction of a moving body. Unbalanced force can change the shape as well as the direction of motion. This difference you can expect in your detailed answer. Okay. Yes. Next, we are seeing what is force, right? What is force? Force is a push or pull acting on a body. It is an external agency applied on a body to change its state of rest and motion. Next, we are going to see the units of force. The unit of force is Newton. Okay, what is the unit of force? The SI unit of force is Newton. In CGS system, what are called CGS system? Centimeter, gram, second system. CGS is nothing but centimeter, gram, second system. In CGS system, the unit of force is dyne. What is this? Dyne. D-Y-N-E. Dyne. In CGS system, the unit of force is dyne. In SI system is nothing but standard international system. In standard international system, the unit of force is Newton. In SI system, the unit of force is Newton. In CGS system, the unit of force is dyne. Yes. Next, we are going to see what is resultant force. Yes. What are called resultant force? If the multiple forces are there in a body, the sum of the multiple forces are represented by a single force called as resultant force. Sum of multiple forces are represented by a single force and it is called as a resultant force. Multiple forces are nothing but two or more forces. If two or more forces acting on a body, then the sum of the forces are represented by a single force called as resultant force. Resultant force is also called as a net force. Resultant force is also called as net force. See here. Sum of forces is represented by a single force called as resultant force. If two forces act on a body in same direction, if two forces act on a body in same direction, then the resultant force is added. If two forces act on a body in same direction, if they act in same direction, then you should add the two forces. Okay, if it acts in opposite direction, you have to subtract the forces. If they act in same direction, you have to add two forces. If they act in opposite direction, you have to subtract. See here, if two forces act on a body in same direction, then resultant force is added. If two forces act on body in opposite direction, then resultant force is subtracted. So here resultant force is sum of multiple forces are represented by a single force called as resultant force. It is also called as a net force. Next, we are going to see what is inertia. What is inertia? Inertia is the inability of a body to change its state of rest unless an external force acts on it. What is inertia? Inertia is the inability of a body to change its state of motion unless an external force acts on it. A body remains in a state of rest unless we apply some external force to make the object move. That is inertia. The meaning of inertia is unchanging. What is the meaning of inertia? Unchanging. Inertia is derived from a Latin word inert. Inertia is derived from a Latin word inert. Inert means inactive. Inertia is derived from a Latin word inert. The meaning for the word inert is inactive. Direction. Yes, what is inertia of rest? The tendency of a body to change the state of rest is called as inertia of rest. What is inertia of rest? The tendency of a body to change the state of rest is called as inertia of rest. Next, the tendency of a body to change the state of motion is called as inertia of motion. In the same way, inertia of direction is the tendency of a body to change the state of direction is called as inertia of direction. Inertia is the tendency of a body, the inability of a body to change the state of rest unless an external force acts on it. Inertia is of three types: inertia of rest, inertia of motion, inertia of direction. Next, Newton's first law of motion. As I have said before, Newton formulated three laws, namely first law, second law, and third law. As Newton formulated these three laws, these laws are named after him, namely Newton's first law of motion, Newton's second law of motion, and Newton's third law of motion. Newton's first law is also called as law of inertia. Newton's first law is also called as law of inertia. What is Newton's first law? Every body continues to be in state of rest or uniform motion unless it is acted upon by external force. Every body remains in a state of rest unless an external force acts on it. That is Newton's first law. Newton's first law and the definition of inertia are similar. Okay? Yes, we have seen the difference between balanced force and unbalanced force. Balanced force are nothing but if the resultant force is equal to 0, then they are said to be balanced force. If the resultant force is not equal to 0, then they are called as unbalanced force. We have seen the difference between balanced and unbalanced force. Balanced force do not change the state of rest and state of motion. Unbalanced force changes the state of rest of a body. It can accelerate or decelerate a moving body. Accelerate is nothing but it can increase the speed and decrease the speed of the moving body. Next, balanced force can change the shape of the body, but it can't change the direction of the moving body. Unbalanced force can change the shape as well as direction of motion. Next, we have seen what is force. Force is the push or pull acting on a body. Unit of force in CGS system. CGS is nothing but centimeter, gram, second. In CGS system, the unit of force is dyne. In SI system, SI is nothing but standard international system. In SI system, the unit of force is Newton. Next, we have seen what is resultant force. Resultant force is nothing but the sum of the multiple forces are represented by a single force called as resultant force. If two forces act on a body in same direction, then we have to add the resultant force. If two forces act on a body in opposite direction, then the resultant force is subtracted. Next, we have seen what is inertia. Meaning of inertia is unchanging. Inertia is derived from the Latin word inert. Inert is inactive. Inertia is of three types, namely inertia of rest, inertia of motion, inertia of direction. Then we have seen Newton's first law of motion. Newton's first law of motion is also called as law of inertia. The next topic that we are going to see is Newton's first law of motion. What is Newton's first law of motion? Every body remains in a state of rest or uniform motion unless an external force acts on it. What is Newton's first law of motion? Every body remains in a state of rest unless an external force acts on it. You see, every body continues to be in state of rest or uniform motion unless it is compelled by an external force. Unless an external force acts on a body, the body remains in a state of rest of uniform motion. That is Newton's first law of motion. For example, a book that is lying on a table. If I place a book on the table, the book will remain in the same position until I apply an external force to replace the book from one place to another. That is an example for Newton's first law of motion. Yes, what is Newton's first law of motion? Every body continues to be in state of rest or uniform motion unless it is compelled by an external force. Example, book that is lying on the derived from the Latin word meaning inert. Inertia is derived from the Latin word inert, which means unchanging. Inertia is nothing but the tendency for an object to remain in same state of rest or uniform motion unless an external force acts on it. The meaning for Newton's first law of inertia is same. So it is also called as law of inertia. Newton's first law of motion is also called as law of inertia. This inertia is of three types, namely inertia of rest, inertia of motion and inertia of direction. Yes, what are the three types of inertia? Inertia of rest, inertia of motion, inertia of direction. What is inertia of rest? An object remains in a state of rest unless an external force acts on it. What is inertia of motion? Similarly, an object remains in a state of motion unless an external force is applied on it. What is inertia of direction? An object remains in a state of direction unless an external force is applied on it. Yes, inertia is nothing but it is a tendency for an object to remain in same state of rest or uniform motion. There are three types of inertia, namely inertia of rest, inertia of motion and inertia of direction. Next, what is Newton's second law of motion? Newton's second law of motion is force is directly proportional to mass and acceleration. The force acting on a body is directly proportional to mass of the body and acceleration of the body. F is equal to ma. Here F is your force and m is mass acting on a body and a is your acceleration. F is equal to ma is the formula for Newton's second law of motion. The force acting on a body is directly proportional to mass of the body and acceleration. From this formula we can calculate acceleration. What is acceleration? A is equal to F by m. Acceleration is directly proportional to force acting on a body and inversely proportional to mass of the body. A is equal to F by m. Acceleration is directly proportional to force acting on a body and is inversely proportional to the mass of the body. A is equal to F by m. We are going to see what is impulsive force. Yes, what is impulsive force? Impulsive force is nothing but a large force acting for a very short interval of time. What is impulsive force? Impulsive force is a large force acting for a very short interval of time is called as impulsive force. Example, blow of hammer. If you hit the hammer on the wall, what will happen? You have to hit it for a long time, right? Yes, that is a large force acting for a very short interval of time. Example, blow of hammer. Next, what is impulse? Impulse is represented by the letter J. Impulse is equal to, impulse is a product of force and time taken. Impulse is a product of force acting on a body and a time interval with respect to the particular time interval. Force acting on a body with respect to particular time interval is impulse. J is equal to F into T. F is your force and T is time taken. J is your impulse. J is equal to F into T. Next, the unit for impulse is, what is the unit for force? Unit for force is Newton. Unit for force is Newton and the unit for time is second. So the unit for impulsive force is Newton second. What is the unit of impulsive force? Unit for impulsive force is Newton second. Newton is the unit for force and second is the unit for time. Next, this impulse is a vector quantity. As both magnitude and direction, it is called as a vector quantity. Impulse is equal to force into time. Unit for impulse is Newton second and impulse is a vector quantity. Why it is called as a vector quantity? It has both magnitude and direction and so it is called as a vector quantity. Next is your linear momentum. Is what is linear momentum? Linear momentum is represented by the symbol P. Linear momentum is represented by the symbol P. P is equal to mv. This is the formula for linear momentum. Linear momentum is the product of mass and velocity. Linear momentum is the product of mass and velocity. It is represented by the symbol P. P is equal to is the product of mass and velocity. This linear momentum is also a vector quantity. Since velocity is a vector quantity, this linear momentum is also considered to be a vector quantity. Yes. Next, principle of impulse and momentum. What is impulse? Impulse is the product of force and time. And what is momentum? Momentum is mass into velocity is momentum. So we are going to equate both impulse and momentum. See, F is equal to, from Newton's second law, F is equal to ma. Now, what is the formula for impulse? J is equal to Ft. Now we are going to equate these two formulas. Okay, J is equal to, what is the formula for F? F is equal to ma. Substitute this ma in equation 2. Instead of F, I am substituting ma into t. Now this a is your acceleration. What is the formula for acceleration? Change in velocity by time taken. Final velocity minus initial velocity by time taken. Now I am substituting the values for acceleration here. V minus u by t into t. This t and this t will get cancelled. So mv minus u. mv minus mu. J is equal to mv minus mu. Impulsive force is equal to change in momentum. This is principle of impulse and momentum. We have equated both impulse and change in momentum. Impulse is, which is equal to change in momentum. J is equal to mv minus mu. See here, impulse is equal to change in momentum. This is called as principle of impulse and momentum. See, from Newton's second law of motion, F is equal to ma and impulse is equal to force into time. I am substituting the value for F in the formula for impulse. J is equal to ma into t. A is your acceleration, which is equal to v minus u by t. This t and this t will get cancelled. So J is equal to mv minus mu. Impulse is equal to change in momentum. This is called as principle of impulse and momentum. So here we have seen what is Newton's first law of motion and what is Newton's second law of motion. What is linear momentum? What is linear momentum? Linear momentum is the product of mass and velocity. What is impulse? Impulse is the product of force and time. Then we have seen principle of impulse and momentum. We have equated both impulse and change in momentum. We have seen what is Newton's first law of motion and what is Newton's second law of motion. Newton's second law of motion is also called as law of force. Newton's first law of motion is also called as law of inertia and Newton's second law of motion is also called as law of force. Now we are going to see Newton's third law of motion. What is Newton's third law of motion? For every action, there is an equal and opposite reaction. Is what is Newton's third law of motion? For every action, there is an equal and opposite reaction. The formula for Newton's third law of motion is Fd, which is equal to minus Fa. Force on B opposes the force on A. Fb, which is equal to minus Fa. This minus sign denotes opposite. It opposes. Force on B opposes the force on A. Fb is equal to minus Fa. For every action, there is an equal and opposite reaction. Example for Newton's third law of motion is propulsion of rocket. Propulsion of rocket is an example for Newton's third law of motion. Yes, next. This Newton's third law of motion explains what happens when one object exerts a force on another object. This law explains what happens when the force exerted on one object on the other object. This Newton's third law of motion explains what happens when one object exerts a force on another object. Example, propulsion of rocket. Propulsion of rocket is an example for Newton's third law of motion. Is what is Newton's third law of motion? For every action, there is an equal and opposite reaction. The formula for Newton's third law of motion is Fp is equal to minus Fa. Force on B opposes the force on A. This negative sign denotes it opposes the force on A. Fp is nothing but force on B. Fa is nothing but force on A. Force on B opposes the force on A. What is Newton's third law? For every action there is an equal and opposite reaction. The example for Newton's third law of motion is propulsion of rocket. This Newton's third law of motion explains what happens when one object exerts a force on another object. What happens when one object exerts a force on another object. Example for Newton's third law of motion is propulsion of rocket. Next we are going to see conservation of momentum. What is momentum? Momentum is the product of mass and velocity. Now we are going to see the conservation of momentum. Conservation of momentum. Law of conservation of momentum is nothing but the total momentum before collision is equal to the total momentum after collision. The total momentum before collision is equal to the total momentum after collision. See here, the bodies before collision will be like this. It will be separated. Okay. During collision, both the bodies will be collided. Collided is nothing but they will be joined together. Okay. After collision, again they will be separated. Before collision, both the bodies will be separated. During collision, they both will be joined. Okay. After colliding each other, they will get separated again. This is see here. See this diagram. Before collision, the bodies will not be same. During collision, they will be joined together, and after collision, they will be separated again. The formula for conservation of momentum is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Total momentum before collision is equal to the total momentum after collision. M1 is m represents momentum, u1 is your initial velocity. So the law of conservation of momentum states that the total momentum before collision is equal to the total momentum after collision. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the formula to calculate law of conservation of momentum. Yes, we have seen Newton's three laws of motion, and we have seen what is linear momentum, law of conservation of momentum, and what is impulse. We have related both impulse and change in momentum. Yes, that's all for today's class. Rest of the topics we can see in your next class. Yes, thank you students. Complete your homeworks and submit it in your WhatsApp group. Yes, thank you.